So to check for the test for homogeneity, so we have here our online calculator for homogeneity of variance calculator or the Leibniz test. And the data, so this is our data. All you need to do, as long as this is already sorted, is to copy now the data for the group of male and paste it in sample 1. And let us also copy the data set for group of female and paste it in our online calculator and simply click calculate. Let us see what is the result. So these are the computations or the solutions if you will do manual computations. The F is 0.0029 and the p-value is 0.957, which indicates that the requirement of homogeneity is met. So which means we can assume that our variances are equal. So let us just report that part in our hypothesis testing. So we have here that F ratio or F is equal to 0.029 and our p-value is 0.9057. So no doubt with the preliminary test, so we are sure that the purpose is to compare two independent samples. We are also sure that our data is at this interval and that our data is normally distributed and that the test of homogeneity is met, so t-test for independent sample is an appropriate test for our data. So step 4 is to generate the result. So first, we're going to use the Microsoft Excel to do that or to generate our test. Let's go back to our data set. So this is our Microsoft Excel. And let's click data, data analysis, and locate data score to sample assuming equal variances. So we have two options here. It's either equal variances or unequal variances. So in case that we did not meet, for instance, the homogeneity or the Leibniz test, then we're going to use the unequal variances. But since the result is P is greater than 0.05, then we are sure that we will use the assuming equal variances. So click equal, and then we will select our data for group 1 or for male groups. So let us just be careful in selecting. Make sure that it's only until this cell. So it's 27. And then the next one, so let us also select our group 2 or the variable 2. So this is the variable 2 down to the last number. Initially, our alpha is 0.05. So let us just retain this value and then simply click OK. So this is now the result of the t-test using assuming equal variances. So in this table, you are provided with the number of observations, that's the n, the variance, the mean, and also degree of freedom. The t is statistics, the p-value and critical value, p-value for one-tailed and critical value for two-tailed also. So just to compute also for the standard deviation, because that is what we're going to place in the table, then we need to place SD and then compute equal sign SQRT open parenthesis and then select your variable 1 variance. Just drag this to variable 2. So this is now our standard deviation. So all you need to do is just to copy this and paste now in our hypothesis testing. And then step 5, let's see. So let's place the decision. The decision is to reject HO. So we use the two-tailed. It's more than 0.05. So we will reject our HO. Or let us also see what if we use the online calculator. So this is the online calculator. So let's go back to the list of the tests and locate where is the t-test calculator for two independent means. So this is the test. So let's click this test calculator and copy paste our data set for group 1 and group 2. Let's go back. So we will select our group 1 and paste it in treatment X for first treatment, and then also group 2. Control C, Control V. So it's two-tailed 0.05, calculate TN. So you will get, the t-value is negative 0.11859. It is the p-value is 0.905, which means that it is beyond 0.05, therefore it is not significant. So the result using our, let's see, where is that table? Let's go back here and compare the results. So we have 0.905. So it's exactly the same result, negative 0.11859. So it is also the same. So the decision is to reject, the decision is to accept the HO. And then we can just arrange our table in this manner. This is the p-value. Where did I get that value? It's actually this value. So negative 0.119. And then for my p-value, since I used the two-tailed, so I'll report this 0.906. And then for the mean and standard deviation, so it's also provided here, 18.66. So this is the data for number 1. This is the male. So we can actually replace this with male, and this is the data for female. And the standard deviation is 7.577. For female, it's 18.84. The standard deviation is 7.601. And this is all reflected here. So for the interpretation, this is the interpretation of our table. So I just indicate here that if the p-value or the test statistics is significant, let us place asterisk if it is significant at 0.05, and if it is significant at 0.01, we will place double asterisk. So since I did not place asterisk here, it means that it is not significant. So for the first interpretation, always compare now the first group with the second group, or the group of male compared with the group of female, because remember that is your purpose why you are conducting this statistical test. So as shown in the table, the mean score of the level of life satisfaction of female students was higher than the male students. So as you can see here, just to support the statements, we also place the values of mean and the standard deviation. And then next, you have to report now the result of the t-test by stating that, however, the t-test for independent samples reveals that there was no significant difference. And you can actually place this value here. Just also to support now with its p equal to 0.0 906. So what is the meaning of this? It indicates that the level of satisfaction of the students is the same regardless of their sex. So that is for the t-test for independent samples. So you have to check first all the conditions before you have to or before you can use the test. In case that you did not satisfy, then you can always use the non-parametric counter